Let's turn our attention to Lesson 8, Setting Up and Solving Problems Involving Compound Interest. I want you to note that this is not the only concept you're expected to learn in Lesson 8. They also introduce compound interest with a table, right? So instead of using a formula, you use a table as reference to help you solve compound interest problems. I have a video, my Unit 2 video does cover many examples of that. I think I have a few of my short workbook lesson videos on that as well. Again, for the purpose of this video, I'm focusing on compound interest using the formula. And that's just based on where I see students historically struggling the most. So for this video, I'm going to keep it brief and I really just want to focus on taking apart the compound interest formula. So first, a couple definitions. Again, you'll run into compound interest tables, which are just tools to help you calculate compound interest quickly without using the formula. You'll see that in your lesson. Compound interest. I said I would explain the difference between compound interest and simple interest. Remember that simple interest was interest accrued on principal only. Compound interest is interest that will earn, like simple interest, on your original principal, but also on the interest earned during previous interest periods. So you end up earning interest on interest. It kind of snowballs. And let me give you an example. So I'm going to write S for simple, C for compound interest. Let's say I take out a loan of $100, okay, and one of my loans has simple interest calculation and one of them has compound, okay? So both cases I have a $100 loan, and let's say in both cases I have a 10% interest rate. So when my interest period happens, when my interest is calculated, the people that gave me my simple interest loan are going to say, okay, what's 10% of 100? Well, it's $10. We're going to charge her $10. And the compound interest people will do the same. 10% of 100 is $10. And so now my new balance with both of these people is $110. So far it's the same. But what happens next month? So next month, once again, my simple interest people say, what's her principal? It's $100. What's 10% of $100? It's $10. Let's tack on another $10 to her account. And I end up owing $120. So notice that the interest accrued was the same both times. This is going to be different for compound interest. The compound interest people, instead of looking at my original principal, are looking at my current balance. Remember, my current balance includes this interest. And they're going to say, okay, well, she owes $110. What's 10% of this number? 10% of this number is $11. And I end up owing $121, right? I end up owing $121. So this is where the change happens. With simple interest, I only owed $120. With compound, I owned $121. This is going to snowball over time. So for right now, it seems like a pretty small difference. You know, it's only $1 off. Over time, if I looked at, for example, the graph of simple interest and compound interest, the money I owe for simple interest will appear as a linear graph. I'll start off owing $100 and it'll just steadily climb upwards, right? Because I have a constant there's a constant rate or a constant amount of money that they're tacking on every month. With compound interest, this is the scarier one, I start out owing $100 and it stays kind of low at first, but as that interest accumulates on top of itself, I grow faster and faster. This is an exponential function, whereas simple interest is a linear function. So you can see why, if you are the one getting a loan, most of us, the loans we take out will be this kind, compound interest, and the money climbs on top of itself faster and faster and faster. Okay, so that's the difference between compound and simple interest. Compound interest, being a little bit more complicated, also has a slightly more complicated formula, which I'll show you in a moment. Also a reminder that your balance is, of course, the amount of money you have in your account. In these lessons, you'll see, and sorry, I know I have writing that makes it hard to see, but You'll see the word amount a lot. Anytime we talk about amount and they don't really give you any context, they're talking about the amount of money in your account after interest has happened. Okay? And I'll show you what that means as we get into the examples in the next video. Here is our compound interest formula. I know it looks a little hairy at first, but really it's not that much worse than the simple interest formula. Simple interest had 4 variables in it. This one has 1, 2, 3, 4, 5 different variables in it. So, it's not that much more complicated. You can still have your calculator do all the work for you. But here's what we're looking at. So remember that A I just mentioned. A is amount. It's the ending balance, the amount of money you have in the account after that interest has accrued. P is still principal. R is still your APR in decimal form. N is the number of times interest is compounded annually. This is the only new variable we're introducing. N is the number of times interest is compounded annually. So, if we were talking about a monthly compounding, N would equal 12. If I said my interest is compounded daily, N would equal 365. If I said it was compounded quarterly, 4 times a year, N would equal 4, right? So it's just based on what keyword they give you, monthly, daily, weekly, etc. Or it could even be annually, which would just be 1 time a year. That's how you'll figure out what N is. And T is still time, and it's still time in years. So everything's the same. It's just, of course, the construct of the formula is different, but our only new variable is N, the number of times per year that interest is compounded. So with that, let's go ahead and move on to the next video where we'll look at a couple of examples of computing compound interest.